Okay, so we're in Module 5 of the semester, and the topic is selecting features in ArcGIS. It's a really common task. We do not have a PowerPoint to go with this topic. Instead, I'll do a demo, and you'll be able to get back to that demo. I'll post this video on Moodle. You should also review all of the learning resources here. There's a bunch of resources on selecting features interactively, by attributes, by location, working with selected features, and exporting features. I'm going to demonstrate each one of these things throughout the course of this discussion, as well as go over the details of the whys and the hows. The learning activity this week is one that we created. It is not in the Esri training materials. So let's just start off by selecting features interactively. Now, I'm not going to read through all this this desktop help information that I've linked for you, but I do want to click on one or two of them just so you can kind of see what I'll be talking about. And you can see that there's a lot of good information with graphics on how to select and what selections do and all that kind of stuff. This is your book for this section of the course, so you're responsible to read through this information. So first off, why do we select features? There's a lot of reasons to select features. Sometimes we have a layer, a GIS layer, with many features in it, and we're just concerned with information about a select few features. So when you select a subset of features out of a layer, you can do things like get information about just the selected set of information. And I'll show you how this works when we start doing some selections. So to get information about a subset of features in a layer, we select them. Sometimes we select features in order to create a new GIS layer. For instance, maybe you have a layer that shows all of the states in the United States, but you want to make a map of North Carolina. You may select North Carolina and export it to its own GIS layer. So a lot of times we select features and then we'll create a new data set by exporting those selected features to a new layer. We also often use selected features to select other features. And again, I'll demonstrate all this stuff as we go through it, through this demonstration. So, to interactively select features, you use this tool right here, which is the Select Features tool. It's got a little white pointer, it's got a little set of polygons with one shaded blue that indicates it's been selected. So, to select features interactively, you simply click on this tool and you select the feature by clicking on it that you'd like to select. So if I wanted to select North Carolina, I'd simply click on it. Okay? So if you can see the feature or features that you would like to select on the map, if you can visually identify them, the easiest way to select them is to interactively select them. Just click on them. Okay? You can select multiple features by doing something like dragging a box, so you can clear your selected set by clicking away from the selected features. If you drag a box, every polygon that box touches will get selected. So dragging a box, it selects everything that it touches by default. You can add to a selected set by holding the Shift button down on your keyboard and clicking on other polygons or other features. Okay? And if I decide I want to unselect a feature that is in my selected set, holding the Shift key down still, I can unselect the selected feature by clicking it again with the Shift key down. So holding the Shift key lets me add to a selected set or remove from a selected set of features. Okay? So let's select, let's say I'm curious about the population across North Carolina, South Carolina, and Georgia. Okay, so let's open this attribute table and look at it. And let's get a feel for what we've got. This is a states layer. There's 51 polygons. That 51st polygon is the District of Columbia. There's 50 states and the District of Columbia in this layer. And there's a bunch of attribute information in here. It is not the most current data available, but it's an easy data set for me to pull up and show it to you. The most recent population data is from 2000 in this data set. So we could get some more current population data, but for the purposes of demonstration, this data set works fine. Now, from the attribute table, before we start working with selected features, I like to show what you can do in a table by right-clicking a field name. If the field stores numbers, you can do things like get statistics on that field. So this is a bunch of numbers, and I could get the statistics on that field. So for the population of in 2000, you can see the count is 51. So we're talking about all the polygons, all the states, plus the District of Columbia. The minimum, the state with the least population in 2000 had 479,673. The maximum had 33 million plus. There's the sum, the total sum of the population of the United States in 2000, the mean, standard deviation, and some other information. You can also right-click a field, and it doesn't matter if it's a number or not, but you can sort, ascending and descending. So I will oftentimes sort fields, and so you might be wondering, what state was that only had 479,000 people in it? Wyoming. So the least populated state in 2000 was Wyoming. So by opening up a table and sorting the fields and looking at statistics, you can get a lot of information about what you're looking at right off the bat. So I'm curious about just these three states: North Carolina, South Carolina, and Georgia. I wonder what the average population of those states were in 2000, or maybe what the total population. Maybe I'm doing some kind of study where I'm looking at these three states and I want to know the total population. So if I open the attribute table now, you'll see that 3 of 51 have been selected. If you browse around enough, you'll see them all. If there's too many records and it's hard to find them, you can tell it just to display the selected records here. You don't have to do that. But here, if I look at the statistics of a field when I have a set of selected records, notice the count is 3, so it's just showing me these 3 states. So the total population of those states in 2000 was 19,648,061 people. The average 6,549,353 across 3 states. So sometimes you select some features. Also, the records in the database are selected in order to find out information about just those selected records. Okay? Now, like I said, interactively selecting features is the easiest way to select something if you can see it on the map. I.e., if I tell you to select Florida, the easiest way to do that is probably just to click it. Okay? And you have Florida selected. Remember, it's kind of a one-to-one thing. For every one feature you select on a map, one record in the attribute table gets selected. So there's the state of Florida. Because I selected it in the map, it gets selected in the table. I can also select interactively in the table by clicking these gray boxes. And if I hold down my shift key, I can add to the selected set. If I want to skip a record If holding the shift key, it'll select everything in between that last selected record and the next one. If I wanted to skip records, I'd click the control key. Okay? So interactively selecting features by clicking on them. Now remember, you can remove selected sets by holding down your shift key and removing a selection. I want to show you a few things under the selection drop-down. The fact that there is a selection drop-down menu, it is one of the main menus in the software, should indicate to you it's something we do a lot. Okay, we make selections a lot. Now, interactive selections are not under this selection drop-down. We're going to look at select by attributes and select by location in just a minute. But for now, I want to look at the selection options. So you can see how you can change some of these selection options in here. The very first one tells you how your interactive selection works as far as that box. By default, it selects anything that box touches when I drag it across. I could tell it to select features that are completely within the box, or select features completely within the box, or graphics. So you can do different types of selections on these, and typically I leave that box as the default. You can change your selection color and some different things in here. Also under the selection drop down, you can change your interactive selection method. And so I was using the shift key to add selections to the current selection. And I was using the shift key to also remove selections from the current selection. So I can, if I click add to the current selection, I can add to the current selection without holding the shift key down. Most oftentimes I hold the shift key when I want to add to a selected set to select multiple things. Occasionally I do change that selection method. I mean, if I need to go through and I need to select like 1,000 road segments going up the side of something, which I've had to do in the past 2 weeks, I will change that to add to the current selection so I don't have to sit there with the shift key down, because eventually after you click and select a whole bunch of them, you'll lift up your finger and click and unselect everything you had selected. So if you've got to select a lot of things, I will occasionally change this selection method. Most often, if I'm selecting multiple features, I just use my shift key to add to the selected set. You can clear the selected features by clicking that button. You can also just click outside away from a feature. If you click where there is no feature with your select features tool, it unselects everything. Oh, I've got add to current selection, so it doesn't because I've got my interactive selection method there. If it's on create new, it gets rid of them, and by default it's on create new usually. So all right. Also, something we commonly do when you get a selected feature, if you right click your layer, you've got this selection option and you can zoom to a selected feature. I do that a lot of times when I'm looking at a map with a ton of data on it, and I select one point somewhere and I need to figure out, I don't have any idea where that point is, so I can zoom into it by selecting it, and that's when I select it by attributes. Obviously if you interactively select it, you know where the point is, so you can zoom to a selected set of features as well. Alright, so that's interactively selecting features. Again, if you know where the feature is that you want to select, or features, use your interactive select tool and click on it. Now, selecting features is different than selecting elements. This black pointer is for selecting things that are not features in a GIS layer. Things like a legend or a title or a text box. So if you want to select something that's not a part of a GIS data set, a feature, point signs or polygons, if you want to select some other map element like a legend or a north arrow or a title or a neat line, you use select elements. This selects features. remember our GIS, vector-based GIS data are made up of features, points, lines, and polygons. All right, so oftentimes we don't know the exact feature we want to select. Rather, we know something like the criteria that we want to select by. And I'm going to add in the counties layer here. And it just comes in with some default color. But let's look at the counties attribute table. There's over 2,000 records. If we do this little move to the end of the table, you'll see there's 3,141 counties in America. All right. You can also sort things like all the fields, and I like to show this because it's neat. What was the smallest county in 2000? 55 people. Right? Scroll over and you can see. This is always a little bit weird. This is kind of a weird example. I don't understand how that county is called Yellowstone National Park part. I'm not sure that is actually a county, but for the example, you can sort to figure this stuff out. What was the biggest county in 2000? Let's scroll to the bottom and look. LA County. Okay. You can also do some pretty neat stuff like freeze fields. So when you scroll, notice the name goes off the table. And really, I want to compare, whatever state this was right here to how many males and females and race and everything else through here. So if you right-click a field, you can freeze it. And by freezing it, it will stay right here, and all the other fields will scroll past it. So it's a nice way to be able to compare different fields, because you can hold one still while you roll the other ones by it. And you can freeze more than one as well. So now it froze both of those. So it's a good way to be able to compare information in a table by holding one field still and scrolling the other ones, because you can compare them side by side. All right, freezing and unfreezing fields. So freeze, unfreeze, I'll unfreeze both of those. All right. Okay, so interactively selecting features. I'm curious where the smallest county is in the country. So, I could go right here and click that and pan over, and there it is. It's a little bit weird. I'd have to investigate that. I've been there, but I'm not exactly sure what's going on there. But that's not the point of this tonight, okay? Okay, so let's say we're curious about all the really small counties in the United States. And someone's asked you to give them a list of all the counties in the United States that have less than 5,000 people in it, maybe. Okay? So, if you want to select the counties that have less than 5,000 people in them, that would be very difficult, or I'd say impossible to do interactively. Just going through on the map and clicking on them. Now, you could do it from the table by sorting, and then selecting all the way down till you find the one 5,000. I don't even know where I am now, right? But that's not the best way to do it. The best way to do it would be to select by attributes. So under the selection drop-down, you can select by attributes. Select by attributes uses something called structured query language. It's a standard language for interacting with database management systems. This is how we ask questions of all databases that you use. When you go to Amazon.com and you search for a tube of toothpaste and you tell it you want it to be 12 ounces and spearmint flavor and Colgate, you give it this criteria, it's filtering through a table of information, and it is using structured query language that gets built by something like this GUI here to extract out records in the table that satisfy your criteria. So, all databases do this again. If you've ever used Microsoft Access, Microsoft Access has this nice little graphical user interface that allows you to build these queries. It's called Query by Example in Microsoft Access. ArcGIS lets you do it with this great tool. It's a nice GUI interface that allows you to build structured query language, so you don't have to know how to write the language. You don't have to understand the syntax of the programming language to interact with the database. So we've got this great tool. It builds SQL and it selects features based on a criteria. These tools are great for learning about this stuff, just like Query by Example in Microsoft Access is a great tool for learning about querying databases. However, they are limiting. You can't make as a robust statement to make complex selections like you can if you're an experienced database administrator who understands the syntax of structured query language really well. Database administrators everywhere write SQL by hand, and that's how they interact with databases. Okay? Or the DBA, the database administrator at the city of Asheville, writes SQL commands all day long to select features in a database. You can update features in a database. You can delete features in a database. There's different things you can do with SQL. So let's look at how it works in ArcGIS. It's important that you know how this works, or you won't be able to correctly create the expression. Now I'm going to zoom out so we can see the whole country and all the counties. Now, you've got your field here, you've got your operators here, and you'll have the values for the fields you choose in here. Now, this is the important part. To build the expression, you double-click the field. Double-click, you see it puts it down here. Double-click the field. You single-click the operator, and then you can get the unique values for that field. So for the population 2000 field, remember the lowest number was 55? It just populated this based on the values in that field. And I said I want to do the ones less than. Y'all are going to let me put the wrong thing in there. 5,000. Okay? Now I don't have to pick the number from here. I just typed it in. When you're querying for a number and all of your features usually have a different number, often do. Like there's probably no counties with the exact same population or very few. So it's not like I have to come try and find 5,000 in here. I know I want population less than 5,000, so I just type in 5,000. You can verify your statement. Tells you it's successfully verified. And if I apply it, there they are. Okay, there's a lot of counties. How many? Down here it flashes 305. So if I give you this data set and I say, tell me how many counties had a population in 2000 of less than 5,000. This is how you would find out. The structured query language that I was telling you about, this is the statement. Select all from counties. I'm selecting from this counties layer where this field is greater than that. So this is essentially an SQL statement that I was talking about. And this GUI builds it for you. You can see it's got some syntax to it, the way it has to be written. You don't have to understand it in this class, but if you get deeper into databases and computers, understanding better how SQL works is valuable. Okay, so I can click OK to this. Now, what's the difference between apply and OK? OK applies and closes the window. Okay, so if you think that you're, if you wanted to change this, maybe I'll look at 6,000. Apply. 370. Maybe 7,000. If you want to evaluate a few different things, you click apply just to leave that window open. If you think you might have to do another query, apply it and leave the window open. Apply doesn't close the window. But you don't have to apply before saying OK. OK closes the window. So here 462, I think I was up to 7,000. How many counties had 7,000 people? That's a lot of small counties, really. I'm a little surprised by that. All right. So selecting by attributes, and that's by numbers. Let's go back to our states layer and look at it again. So this time, who knows which one of these polygons is Iowa? Some of you. Don't feel bad if you don't. We can select by attributes to find out. The one to the right in Nevada. So let's look and see. So everyone knows where Florida is. I bet you occasionally might run into a person that might not know some of the interior states, right? So the point is, we know the database has a state name in it, so we can select by attributes again and select for the states layer. Make sure you're choosing from the right layer, where state name, double click state name, single click equals, and when you click get unique values, it gives you all the values for state name. So if I start typing in, and I don't have to type that in, but I'm going to double click it this time instead of typing it in. Remember, I typed in 5,000, and you may or may not have noticed the numbers did not have single quotes around them like Iowa does. When you are selecting by attributes for number fields, the numbers do not have single quotes. If you're selecting a text field, they have single quotes. We could have typed that in there without picking it from the list, but you would have had to put single quotes around it and would have to be spelled exactly right. It is case sensitive. If you did lowercase IOWA, it would not have selected it. Okay, so apply. There's Iowa. I think you were off. That's okay. That's all right. It's not the point. So, how about selecting for multiple values? So when we selected for greater than 5,000, it selected a whole bunch of values in a field. When you're doing it, when you're selecting by attributes for fields that have text in them, we build what are called compound or multiple criteria query statements. So we make these compound statements. Now, I could add a state to this selection by changing my method here, and I could add to the current selection and put in another expression. State name equals South Carolina. It would add South Carolina to Iowa being selected. Okay, but for now, let's clear our selected set and let's look at how to do a compound query statement. Let's say I wanted to select North Carolina and South Carolina. I'm going to clear my current statement, and I'm going to say I want state name equals to North Carolina or state name equals South Carolina. Now, what you need to know about this statement and where I see students go wrong most often, the first thing they will do is they will say and instead of or. The second thing they will do is they will leave out the second state name. They'll say state name equals North Carolina or South Carolina. The field has to be in there both times, even if it's the same field. And if you're searching for multiple values, North Carolina and South Carolina are two different values within one field, the field being state name, you use or, and I will open the attribute table to describe why. This query statement is very explicit about what it does. It goes through this state name field and it looks at one record at a time. It looks at that one individual cell and it says, does that cell equals North Carolina Or does that cell equal South Carolina? No, it doesn't. Does this cell equal North Carolina or South Carolina? No, it doesn't. This one does. This one does. If you said and, it would look at this cell and it would say, does that state name equals North Carolina and South Carolina? And that cell does not equal North Carolina and South Carolina. Okay, so you got to use or for multiple values within one field. If you're looking across fields, like maybe you wanted to know all the residential properties, if you had a parcel layer that had a zoning type for each polygon. Imagine this said zoning, and it was commercial, residential, commercial, and you wanted to know all the commercial polygons that were greater than an area of a certain size, you would use and. Okay, so if you're searching for multiple values across two fields, you use and I'll come up with an example of that as we go. Okay, so multiple criteria or compound query statements. Now there's also another way to skin the cat here. We could use what's called a wildcard. Wildcards allow you to make more flexible and powerful query statements, really. So let's load some data in here from the city of Greenville and look at it. Let's insert, not insert, let's add some data. Let's click the add data button. I can't even find it. Where's my add data button tonight? I moved my toolbars around, so let's just add it from over here instead from the catalog window. We've got this city of Greenville GIS data over here, and I use it a lot for query demonstrations. There's this major roads layer here. All right. Now, without a selected set of records, you can zoom to a layer, period. And that's, oftentimes we have layers that have very different extents. I want to zoom into one. So a quick, easy way to zoom into where these major roads are in Greenville, South Carolina, right-clicking and zooming to the layer. And that just zoomed into South Carolina. I could turn off I'm going to clear my selection here. I don't really care about those. And let's look at this attribute table for a second. Now, suppose you were asked to select all of the South Carolina highways out of this road, out of this major roads layer. So these are the major roads in Greenville, South Carolina. So there's some interstates and some federal highways and some state highways and a few other major roads. These aren't all the roads, though. And so if I was asked to select all the South Carolina state highways out of this, well, I don't see a field that says whether it's a state highway or not. There's no field that says state highway, federal highway, interstate. But just cruising around in here, I look and I see this field has SC in it. So let me sort this ascending and look at it a little closer. Here's a bunch that don't have state numbers. These are probably county roads. If you scroll down enough, there's interstates. Oh, look, there's the SC highways. They've got this state number field. So SC 124, SC 146, SC 183, SC 20. How do I select all those state roads? There's a bunch of them. I could select by attributes. Now, I've shown you how to select by attributes from up here. If you have the table open already, you can select from the table just by clicking this. And the difference is you don't have an option to change what table you're selecting from if you open it from a table. It assumes you want to select from this table. Remember when we did select by attributes from up here, you can select from any layer in the map document. If you open select by attributes from a table, it says, oh, he wants to select from this table. So I want to select, what was it? State number. I want to select state number equals get unique values. SC124 or state number equals SC146 or state number equals SC183. I could do that, but that's not the best way to do it. What wildcards do is they are a variable that allows you to substitute either a string of characters or an individual character for the wildcard. And this is also not a GIS thing. Wildcards are a database computer concept that has been applied to GIS. You'll see wildcards in every database you ever interact with. And these are the two wildcards. The underscore is if you are trying to search for an individual character, any character. The percent says search for any number of characters instead of one character. And I'll show you both examples. So, what you do is we want anything that starts with the SC but then ends with anything else. So you put the wildcard in where you want the numbers to be replaced, right there. Okay? That space matters sometimes, so we'll talk about it as well. So let me clear this statement. And I want to know where state name is not equal, because we're going to look for multiple values. When you use a wildcard, you have to say like instead of equals. State name like. I'm going to double click the first one here. And I'm going to highlight 124. And I'm going to click this percent sign. Okay? So that's going to select anything that starts with SC, has a space, and then any number of characters. So it would select South Carolina space South Carolina 1. It would select South Carolina space 123. It would select South Carolina space 123 South. Any number of characters out there. Okay? So, if I click apply, those are the main South Carolina highways going through. And to evaluate if it looks like it did it right, you can just look in here and it looks like all the SCs are selected, but the USs are not. Alright? So why is that space important? Having that space right there, it is important. In this case, if I'd put that percent where the space is and did not include the space, in this case, it's going to give you the exact same answer. But what if there were some records in there that said SC123 without the space? Okay, having the space in there would not allow those to get selected. So you got to pay attention to that space. It may or may not affect your selection, but know that it can. Okay, so how about this underscore one? Let's look at, let's say I wanted to select any U.S. highways that had 3 characters. Notice there's some U.S. highways with just two numbers in the state number. So I'm going to do this query again, and I want to select everything but US 20, all the US highways except for US 29. I'm going to get 29 South though. So if we go to select by attributes, let's clear our selection first. And this time we're going to do state name, like, space. I will oftentimes start building the expression like this because it makes sure that I get the single quotes I need and all that stuff. I'm going to go back 3 spaces and I'm going to do underscore once, twice, 3 times, 3 underscores. That's going to force this thing to only select values that start with US, have a space, and then have 3 characters after. So if you wanted to search for a database for all the Toms and the Tims, you could say name equal T underscore M, and that 1 underscore would means it's going to search for 1 character between the T and the M, Toms and Tims. Okay? So wildcards. So if I apply that, it didn't select the US 29s. because there are only 2 characters, but it selected all the U.S. highways that were 3 characters. Okay, so wildcards. Again, not really a GIS concept, it's a database concept, but GIS is a database. GIS are databases that are also spatially enabled. You might be thinking, %sign, I thought the wildcard was an asterisk. Wildcards vary by database format. Some databases use some wildcards and some databases use other wildcards. And depending on the type of GIS data you're looking at, you'll even see these 2 wildcards change sometimes in here. If you are, right now we're searching for on a shape file, we're querying a shape file. The database format is a DBF file. These are the wildcards for DBF files. If you query a geodatabase feature class, you will see a question mark for 1 character and an asterisk for multiple characters. So that's why you see those things change occasionally, because they are based on the underlying database format that we're working with. All right. Okay, so we've covered select by attributes, we select for text values or number values. We double click our fields, single click our operator, and double click our values. It builds these structured query statements. We can make compound statements, and we can also use wildcards to make our queries even more flexible. So let's close this, and let's close this, and let's zoom back out to our South Carolina example, or South and North Carolina example. Let's turn off major roads, and let's add another layer in here. Not from that. Okay. Quakes. This is some quake history data, and it's pretty old. It doesn't have any recent quakes in it. In the exercise you're going to do, you're going to use some more recent quake data. And something I need to mention about the exercise is the quake data that you're using, I downloaded from a website, and I downloaded the 30 days previous of earthquake data from that website when I downloaded it. So the exercise is going to ask you about the last 30 days worth of earthquakes. That's the last 30 days based on that data I'm giving you. It's not the actual last 30 days from today. The data I give you in the exercise, you could go to the website where I've got it and get your own data. The exercise data, all of the links to where I got the data are provided, but I also provide the data to you for convenience. So I encourage you to go explore those websites, but it's not required to complete the exercise this week. So what if you wanted to know how many of those earthquakes points were in North and South Carolina? So this is the final kind of selection we'll talk about tonight, is selecting by location. So because this is a GIS, we can select features based on their spatial relationship with other features or even within a layer. So the select by attributes is really no different than any other database management system. Microsoft Access, Oracle, SQL Server, no different. When you start being able to query features based on location on the map is what makes GIS a little bit different than a typical database management system. So we could start selecting these. Well, that's in South North Carolina, that's in North Carolina, so I'm using my shift key. How many are in these states? Well, you could do it this way. All right. Now, that's not the best way to do it. With an easy example like this, that would probably work because there's not that many points falling in those polygons. But we're going to do it by select by location. So one thing I do want to point out right now is that number that flashes in the bottom of the screen, the number of selected records down there, it said 10. If I select another one and look down in the bottom left corner, see how there's 10 features selected? That is the total number of features selected in all the layers. So if I were to ask you right now how many earthquakes are selected, be very careful of that number in the bottom left. That's not how many earthquakes are selected. That's how many total features are selected. And if you want to see how many earthquakes, the easiest way is to look up here at your layers and list them by selection. So if I click that, you'll see there's 9 earthquakes and 1 state polygon selected. So the point is, be careful of that number that flashes down there. And I'll show you again why. So I told you that sometimes we select features in order to select other features. Now here you can see not all the earthquakes are even on the mainland of the U.S., in the continental U.S., right, that are recorded in this layer. So let's look at what select by location does before we make a selection set in the states layer. Now you have to really look closely at this dialog to understand what it's doing. You read the top paragraph. We're going to select features from one or more target layers. The target layer is what you want to select from based on their location in relation to features in the source layer. So if I asked you how many of these earthquakes in this layer fall within one of these states, you could select from the quake history layer based on their relationship to major roads. No, based on their relationship to states. And then you have to choose how they interact with each other. Now this drop down has more options than I wish. Anything in parentheses you can disregard. If the parentheses say 3D, that means you could search based on their relationship with a Z value too. And we don't do that in this class, so forget the 3D. The Clementini, I don't even know what that does. That should make you feel a little bit better about learning about GIS. We don't all know everything. That got stuffed in here a couple years back, and I haven't had a reason to use it. And I've got a lot of other things to learn. I haven't figured that out yet. Okay? I haven't seen a reason to. So you will use the other ones. So if you say intersect, what it's going to do is it's going to select any quake that falls completely within one of these polygons or that touches that is right on the line. So that earthquake right there would get selected because it is right on that boundary. Okay, if you said intersect. If you said are completely within the source layer, how many quakes are completely within the states, that one won't get selected. So the method of selection you use depends on oftentimes your business rules, whether or not you're looking for things that fall completely within or maybe just touch. It also depends a lot on what kind of geometries you're comparing. One example I do a lot of is buildings in a floodplain, and buildings that kind of halfway are in a floodplain and halfway out. If you say intersect, it's going to select those buildings. If you say are completely within, it's not going to select those buildings. So what I say when I say that sometimes it depends on your business rule, I don't know anything about flood insurance or whether or not a building can be halfway in a floodplain or if it has to be completely within or what. But if you were someone looking at that kind of thing, you would probably have a reason for wanting to either select a building, all the buildings that touch the floodplain at all, or just the ones completely within. Okay? A lot of times intersect, if you're looking for points and polygons, more often than not, you don't have a point right on that boundary. So intersect and completely within give you the exact same answer. Okay? A lot of times. So let's just do intersect in this case. And in the quiz, you'll be doing a queries quiz eventually. I tell you which one of these methods to use. I say use intersect. Tell me how many of this are within that. Use the intersect method. I'm not trying to trick you or anything. All right. So if we scroll out, you'll see the ones that got selected just within the United States. Okay? All right. So it did it based on its relationship to that other layer. How about if someone said to you, well, I really want to know the ones that aren't on land. I want to know the ones out in the ocean. I'm concerned about tsunamis. Which one of these earthquakes might have caused a tsunami? Well, we don't have any polygons out here to select these features by, but since we were able to select these, we can right-click this layer and we can switch the selection. So sometimes you select features based on some features you have, and then you'll switch the selection out. So all these might have caused a tsunami, except for these up here in Canada. But switching the selection. So when you right-click a layer over here, you get a context menu, and notice it looks a little bit different. Since I'm viewing my table of contents by selection, I get all these selection options when I right-click. So your context menu, which is your drop-down menu, varies based on where you right-click. All right. So then, what if somebody says to you, well, let's open this attribute table. Let's look at these selected records. Well, you know, I'm not really concerned with the small earthquakes off the coast. They're not going to cause a tsunami. Let's look at these things. Let's sort ascending by magnitude. Boy, there's a bunch with none. There's a bunch up to, I really think the ones over 5 and 5.5 and bigger, okay, are the ones I'm concerned with off the coast. So I just used a select by location to select the ones inside of the states. Then I reversed the selection to select all of the ones outside of the states. Then I could do an attribute query. I could combine with my location query an attribute query. I have a selected set of records, and really I want to know the ones that had a magnitude of 5.5 or greater. So let's double click magnitude greater than or equal to. I'm going to say get unique values. I didn't have to do that. I could just type 5.5, but I know there's a value in here for 5.5 because I saw it in the table. But be careful. If we do this right now, it's going to create a new selection. It's going to select all of the ones that are 5.5 in the whole layer. What I'm trying to do is, out of the selected set of earthquakes, I want to select from the current selection. These ones out here, I want to know which ones of these are greater than 5.5. So I changed that method and apply it, and it got rid of some, down to 131. You can see it's only 5.5 and above. So you can kind of use this to filter down through values and features based on your queries. All right. So how about how many features, let's do another one. How many earthquakes are in North and South Carolina? The first thing you should do, if someone asked you how many earthquakes were in North and South Carolina and you had these two data layers, you need to select North and South Carolina first. Okay? Because then you can tell it to select the points that fall within the selected records. What we did the first time was we selected the points that fall within all of these states. Let's select by attributes where state name equals North Carolina or state name equals South Carolina. So we did an attribute selection. Now let's go to select by location. And let's select features from quake history that intersect the states layer, but this is the button that'll get you what you want here. Just use the selected features in my states layer. So this is going to select the points, the earthquakes, that fall within the selected features in my states layer that intersect. Pay close attention to this because a lot of people will try to add to the current selection because there are some selected features, but those selected features are not in our quake history layer. This selection method works on your target layer here. So there's no quakes selected, so there's nothing to add to. You want to select. And if I click apply, there they are. So if you look down there, is that how many? 33 bottom left? Are there 33 earthquakes in this layer in North and South Carolina? No, because there's 2 polygons selected. That's the total number of features selected in that whole map. There's actually 31, and you can see that there. Okay. Again, just be careful of that number that flashes up down there. People see it and they think it's what they're looking for, when sometimes it's not. All right. Okay. So that's combining attribute and location queries together. Now, a couple final things. If you get a selected set of records, you can export them to their own GIS data layer. So if you wanted to create a layer of earthquakes for North and South Carolina, since I have them selected, I could right-click this layer and I could go to Data and Export Data. We'll talk about saving as a layer file in just a second. Exporting the data creates a new GIS data set. When you go to Export Data, by default, it's going to want the selected features. Just export the selected features. You've just spent time selecting some features. They think you probably want to export those selected features. And oftentimes we do. If your data has projected on the fly into this data frame, you can have it take on a coordinate system and project on its way out. Your output feature class. Export it to your project folder, your project database. I'm just going to dump this to the documents folder. Don't call it export output ever. Name it something descriptive. What is this? It is NCSC quake history, right? If you name it export output and then you do it again, it's going to call something else export output 2, and the next thing is going to be export output 3, and before you know it, you're going to have a bunch of GIS data. You have no idea what it is from looking at the name of it. Okay, name things descriptively. So this is the quake history. If you had a geodatabase, you could export it to a geodatabase feature class too. You have to have a database built, created, in order to export to it. So that's a big reason a lot of times in my examples I just go straight to a shapefile because it's just quick and easy. So export that, and it's going to say, hey, do you want to add this layer to the map? Sure, why not? There's my new quake history layer. Let's clear my states. Now, there's my earthquakes in North and South Carolina. Okay, so we oftentimes pare our data down to our study area. We are all the time doing this in one method or another, where you start working in an area like, say, you're working in North and South Carolina, but the data you're downloading covers a bigger area. So you're trying to pare your data down to your study area. Maybe if you're working in Buncombe County and you download a roads layer from the state and it extends beyond Buncombe County, you try and get the data pared down to your to your study area. So exporting data. Now, often people will do this. So be careful with selections. Another thing that's worth mentioning, because we have so many overlapping layers in a GIS, a lot of times you select more layers than you want to select from. So you could right-click an individual layer and go to selection and clear the selected features in an individual layer. Clicking that button right there clears all selected features. You can also toggle layers on and off as far as whether they are selectable. By clicking that button in your list by selection, that makes the states layer not selectable. And we do that a lot because we're selecting things and the states keep getting selected by accident. So you can make layers unselectable essentially. And it's helpful. All right. Now the final thing is a quick word on layer files. if you right-click a layer, you can save as a layer file as well. What a layer file does is a couple of things. Let's change the symbology here. Let's say we want them all to be red stars, okay? Now, if I save as a layer file, it does two things. It creates this .lyr file. It points to your existing data. It points to this original quake history layer. And it also saves the symbology of the data. So a layer file saves symbology and labels, but it references the GIS data that it came from. So a layer file is no good without the data that it references. When you export data, you've got a completely new GIS data set. Saving a layer file, you still need the original source data. What the layer file does is it saves symbology. So a lot of times we'll share a layer file with someone if we want them to have the data symbolized on their map the same way you have it symbolized on your map. And you can combine a layer file with its data in something called a layer package. So remember, every time you load data into ArcMap, it just loads it in as a random default symbol. So watch this. When I load quake history back in here, is it going to come in as those stars? No, it's just going to come in as a point layer with some default symbol. The actual GIS data, it stores coordinates and attributes. It doesn't store symbology. Symbology is something that you do in the map. And once it's in the map and you create the symbology you want, you can save that symbology to a layer file and share the layer file and the data with someone so that they have it symbolized the way you want. A good example would be like zoning data for a city. A city has a zoning layer, right? Let's look at Asheville here in my Asheville GDB. Let's insert a data frame. So I've got this blank canvas to work on. And let's look at our counties. What is it? Zoning county layer. There it is. All right. So the county zoning department makes a bunch of zoning maps. And the commercial are red on their maps, right? So they don't want you to symbolize and make a county zoning map where you symbolize things different colors than, what am I doing here? Okay, that data doesn't have quite what I thought it did in it. Oh, there's zoning code. So I was doing it by quantities, not by categories. Zoning code is not a numeric field. Let's add all the values. That's not the right one either. That's the right one. All right, so it just gives us default colors on this ramp, right? Now, the county doesn't want you doing that because they've got all their zoning maps and they'd like for you to use the same set of colors they have. So once you've spent a bunch of time symbolizing a map like this, we often save it as a layer file. .lyr. I'm going to put it in my documents folder and save it. And now, if I go to add to a new map here in my documents folder, notice I got the zoning.lyr file over here. If I load it into ArcMap, it's going to symbolize it the right way. That layer file by itself doesn't work. That layer file points to that source data, that zoning layer in my database upstairs on the server, and it tells it how to symbolize it. If you make a selection set, you can make a layer file that also only shows selected features and symbology and labels, so it does more than just symbology. But that's mostly what layer files are for, storing and sharing symbology between people. So if you want to share that with someone, you can create a layer package what that does is it combines that layer file with the data, puts them together, and then you can give that to someone and it extracts onto their system. If you want to take it a step further, you can create what's called a map package by share as a map package. What that does is it takes all the data in a map with all the symbology and labels and anything else applied in the properties, combines it all together, and you can give it to someone and they can extract it onto their system and they'll have the whole map with all the data. Okay, so map packages are also kind of a related thing. All right, let's look over here at Moodle real quick and see if we covered everything. I think we did. In the assignment, there's a couple other things to pay close attention to, one of which is joining tables. Oftentimes we get data from somewhere other than a GIS, and the data is not tied to a GIS. Okay? We see it all the time, and you can combine data in different tables as long as they have a common field like state name. A good example would be unemployment rate by state. We could easily go to the Unemployment Securities Commission and we could download an Excel file that had by state name the unemployment rate. And you could combine it with this table to symbolize the states by unemployment. So it's called joining tables together. Okay, and it's also a database concept. It's a relational database management system concept. Pay close attention to that in the exercise. That's a good thing to get out of the exercise, in addition to the selection concepts that you'll see. The earthquake data, you'll notice something really odd about the earthquake data. I will just say that I've been working with earthquake data since I started teaching, because it's always been an easy data set to download and work with. What I saw and found when I did this exercise a year and a half ago when I wrote this up, I didn't do it with any hidden agenda by any stretch, but it's pretty interesting the pattern that you'll see in the earthquakes. So pay attention to the pattern you see, and you can draw whatever conclusions you want. I saw an article about it today in the paper, or on the interwebs, not in the paper. So pay attention to the earthquake data you look at. It's pretty interesting. There are some noticeable patterns for where earthquakes are occurring and their frequency. So check that out as well. All right, thanks for listening. Any